Hello students, this is Learning Target 9C. It's on section 12-3 of your books. We're going to analyze geometric sequences and series. This is considered part 1. We're going to go ahead and read our learning target for this week. So one of our learning targets for this week is I can write geometric sequences with an explicit formula or a rule and use them to model situations. So we're going to write geometric sequences with an explicit formula or rule, and then we're going to use them to model situations. All right. So the first thing is I want to talk about a geometric sequence. We already did arithmetic sequences last week. So geometric sequences is basically when you have the ratio, when you take the ratio of any term to the previous one, and it has to be remain constant. So the word constant here means it has to stay the same. So we'll go over an example shortly to illustrate how can you tell if it's a geometric sequence or not. But again, we're taking the ratio. Ratio means is we're dividing the any term by the previous term. And once we get it for all the terms in the sequence, then they have to be the same. So constant. All right. So the common ratio is equal to the constant ratio. So that's another variable that we're going to denote here. We're going to use the letter R. Okay, so we have a formula that we're going to know with geometric sequences. It's a special rule that we're going to use. It's known as the common ratio, also referred to as the constant ratio. All right, so here's our example. Number 1, focus here on the left side. Example 1, here are the directions. It says tell whether the sequence is geometric. Okay, here's our sequence. 4, 10, 18, 28, and 40. How can we tell if it's geometric? Well, basically what we have to do is, it's geometric if we find the ratios of any term to the previous term, and it has to be constant, right? So that basically means if this is 4, then that's my A1. So notice I labeled it right here. Then we have 10, A2, 18 is A sub 3, 28 is A sub 4, and 40 is A sub 5. So we're going to find the ratios of consecutive terms. So what are my consecutive terms? We're going to start out with A1 and A2. So remember, we're going to find the ratio of the previous term. So it's going to be A2, A sub 2 divided by A sub 1. So in other words here, A sub 2 is 10. So it's 10 divided by A sub 1, which is 4. So 10 divided by 4, when you simplify it, you divide by 2 here. So that's the GCF of 10 and 4, and you get 5 halves. Now, you have to continue this process as you go and from one term to the next, okay? So that's going to be with the A2 divided by A1, that's the ratio. So now we're going to do A3, A sub 3 divided by A sub 2. And again, we got 5 halves for this one. In order for it to be geometric, we have to get the same result here. It'll have to be the same as 5 halves. So A sub 3 divided by A sub 2 will give us, well, A sub 3 is 18, and 18 divided by 10, which is A sub 2, will give us 9/5. Once we divide by 2 and simplify the fraction 18 over 10. So notice right here, 5 halves and 9/5. These two are not the same. They're not constant, right? So since they're not the same and constant, we could already tell that this sequence is not going to be geometric. Once you know that one of them is not the same as the other one, then you can just go ahead and stop there. Okay, now just to show you the work for the rest, you have A sub 4. If these two were to be the same, you can continue the rest. So you see A sub 4, that's 28 in this case, divided by the previous term, which is A sub 3. So again, 4 minus 3 will be 1, the previous term. That will give you 28 divided by 18, which reduces to 14 ninths. Notice again, 14 ninths is not equal to any of these two above. So the final ratio, A sub 5 divided by A sub 4 will give us 40 divided by 28. So again, 40 comes from right here, A sub 5, and then 28 comes from here. So you divide by 4, that's the GCF, that will give us 10 over 7. So we know that 10 over 7, so 14 over 9, 9 over 5, and 5 halves are not the same. So they're not constant. So in this case, the ratios are different. So the sequence is not geometric. Okay, so that's 1A. We're going to do one more to see if it's a sequence. The sequence is geometric. So let's take a look at 1B here on my right hand side. So as you can see, we have 625, 125, 25, 5, and 1, and then dot, 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 meaning it continues on with the pattern. So right here, again, first thing to do is check to see if the ratios are going to be constant, right? So what we have to do is find the ratios of the previous term. So we'll start out with A2 always, divided by A sub 1. And then that gives us 125 divided by 625. These two numbers have 125 as the greatest common factor, so you divide by 125, and we end up getting with 1 over 5, or 1/5. Then you keep testing the ratios again from the previous term. So now we're doing A sub 3 divided by A sub 2. So in this case, it's 25 divided by 125. And notice again, they have a GCF of 25 for this one, these two numbers, 25 and 125, so you end up with 1/5. This is a good sign in terms of it being geometric because they have to be the same or constant. So if we keep going with the other ones, then we should be able to get one. If we get 1/5, then that implies that it is a geometric sequence. So since you see it here, you definitely know that it's going to be a geometric sequence. But let's go ahead and go over the details here. So again, we left off right here. A sub 4 is here, it's 5. And then A sub 3 is 25. So again, you're dividing the term divided by the previous terms for each one. We already did the other one. So it's 5 divided by 25 here. And then they have a GCF of 5. So 5 divided by 5 is 1. 25 divided by 5 here is 5. So notice we get 1/5. So again, it matches the previous two. And finally, last but not least, is A sub 5 divided by A sub 4. In this case, it's 1 divided by 5, which is already simplified. So notice we just get 1/5. So notice all of these ratios gave us 1/5, which means that each ratio is the same and it's constant. So the sequence is geometric. Okay. All right. This is the first part. Please review it. Any part, if you have any questions, make sure you take some notes of each problem. Take all the notes for each problem to make sure you can upload that in your assignment. All right. Here's part 2. All right, part 2 involves knowing the rule for geometric sequence. Feel free to pause the video at any time so that way you can take notes and review it, okay? All right, so again, this is the rule for a geometric sequence. The rule is basically A sub n is equal to the A sub 1 times R to the n minus 1 power. All right, so let me go ahead and emphasize what these mean. So remember from before with the arithmetic sequences, A sub n is basically the nth term. In this case, it's the nth term of a geometric sequence since we're focusing on a geometric sequence. Okay, so basically whatever term value that we're focusing on, that's your A sub n. And then right here, your A sub 1 is the same as before. It's your first term of your series. The new one here is the common ratio. Again, it's your R. We find the R by, again, finding the ratios, just like we just did previously to this two problems previous to this. And then it's n minus 1, the exponent here, because, again, to find if it's the geometric sequence, we have to subtract 1 from the other to get to the next one. So, again, if we're at let's say A sub 3. So how do we get to the previous one? We subtract 1. So it's 3 minus 1. So that'll be A sub 2 and so on. So again, this comes from subtracting 1 and thinking about the geometric sequence of the previous one. So based on the definition. Okay, so that will always be n minus 1. Here's an example in words just to illustrate how we can use this. So right here it says the nth term of a geometric sequence. So they're already telling us that it's a geometric sequence. So we're going to be using this general rule or formula with a first term of 3. So they're telling us that the first term, A1, is 3. And then the common ratio is 2. So it's given by, so again, they give us two things here, the first term and the common ratio. So remember the variable that they represents the first term is A sub 1. So I wrote A sub 1 equal to 3 here. Then the common ratio is represented by the variable R. So R is equal to 2. So the formula is A sub n equals A sub 1 times R to the n minus 1. So all we have to do here is, once you find these two pieces of information, then you can just substitute. Okay, so right here is A sub n stays the same. We're finding the nth term of a geometric sequence. The A sub 1, the first term was 3, times R, which is the common ratio. In this case, they gave it to us and it was 2, and then 2 to the n minus 1 power. So again, make sure you put parentheses here because we know we have to do exponents first and then multiply at the last if they ask us to calculate any of these problems that involve finding the nth term of a certain number. Okay? All right. So here's our first problem using our rule to find the rule for the nth term. Directions state, write a rule for the nth term of the sequence, and then you're going to find A sub 7. Okay, focus your attention on example 2a here. We'll do example 2b in a second. Okay, so here's my problem. My problem is 4, 20, 4 comma, the sequence is 4, 20, 100, and 500. And then it's dot, dot, dot. So that means it's going to continue on forever, and it's going to repeat the same pattern. So in this case, the first step is to figure out what your first term is. So notice our first term is your A1, A sub 1. So A sub 1 here is 4, so I labeled it down here. And then 2, I need to figure out what my common ratio is, right? So we just need these two in order for us to write down a rule for the nth term of the sequence. So I already found A sub 1. All we're missing is a common ratio, R. So how do we find the common ratio R? Because they didn't give it to us in this sequence. Well, what we do is we find the ratios of each previous term, right? So for example, we're going to take 20, because that's the second term, and we're going to divide it by the previous one. So right here, it's going to be 20, A2, A sub 2 divided by A sub 1, 20 divided by 4 is 5. And then we're going to go ahead and continue the pattern to find the ratios. We're going to do A sub 3. A sub 3 is 100 here. And we're going to divide by A sub 2, which is 20. So 100 divided by 20 is 5. This is a good sign. So notice these two are 5s already. So we're just going to double check and just to make sure that the common ratio is 5. So we're going to do the last one. A sub 4 divided by A sub 3. So A sub 4 is 500. A sub 3 is 100. What's 500 divided by 100? Well, it's 5. So this implies, since they're all the same, that the common ratio is 5. Now that we have the common ratio, what do we think we have to do? Yeah, we're going to go ahead and substitute that information into our general formula or our geometric sequence rule. So in this case, we know that A sub 1 was 4, and we just found the common ratio, which is 5. So we put it in here. So the final answer for the nth term of the sequence, the rule, is A sub n equal to 4 times the quantity of 5 to the n minus 1. Okay, here it is. All right. Take a moment to pause the video if you need to review and recap some of these steps. You're ready to go. Go on to 2B. 2B is right here. Okay, notice it's a different sequence now. It's 152. Then it goes to negative 76. Then continues to 38. And finally, it goes to negative 19 before it continues on forever with the same pattern. So notice what I did here. In order for us to find the general rule of the nth term of the sequence, we need to figure out two things again. We need the A sub 1, and we need to figure out the common ratio R. So I already labeled A sub 1 here, so I wrote it down. A sub 1 is 152. Then we need to label A sub 2, A sub 3, and A sub 4 because we're going to find the common ratio, or we're trying to determine what the common ratio is, okay? In this case, the common ratio, we start by doing A sub 2 again, divided by A sub 1. So it's negative 76 divided by 152. Now, these numbers are pretty big, and you might think they have a 2 in common, which they do, but you always want to shoot for the GCF, the greatest common factor. So in this case, always try the smaller number first, just to see if it simplifies and it goes evenly into the bigger number here, okay? In this case, 76 does go into 152, so you divide both the numerator and denominator by 76. Notice there's a negative. Negative divided by positive is negative, so be careful. Take care of the sign first. And so you're going to get negative 1/2 once you divide both of these by 76. Okay, so we got negative 1/2 as the ratio from a sub 2 divided by a sub 1. So now we're going to test a sub 3, which is 38, divided by a sub 2, which is negative 76. So 38 divided by negative 76. Once again, the numbers are pretty kind of big. So again, test the smaller number, which is 38. See if 38 goes into 76 to find the GCF. And guess what? The GCF is 38. So you divide both the numerator and denominator by 38. Again, it's positive divided by negative is negative, so keep the negative answer. And then right here, you're going to get negative 1/2 once you go ahead and divide those two numbers. So you're going to get negative 1/2 again. Okay? Now, just because you get these two the same, that does not mean that you don't need to check the last one. Just make sure to show all that work to be safe, okay? And you could always troubleshoot later if you made a mistake. Okay, so how do you get the last one? Again, we're looking at our fourth term here, a sub 4. We're going to divide it by the third term, a sub 3. You have negative 19 divided by 38. Notice 19 and 30 are a little bit smaller, but you also kind of, 19 is a prime number. So if they have something in common, it will be 19. So you divide both by 19. And 19 does go into 38 two times, so you're left with negative 1/2. So notice that the common ratio here is the same for all of these, so it's negative 1/2. So R is negative 1/2. Now that we have our R and we have our a sub 1, our first term, and then our common ratio, we can now go ahead and substitute that to write our rule for the n terms of the sequence. So the final rule is a sub n equal to 152. Again, our 152 comes from the first term, always. Then we have our common ratio R, which is negative 1/2. So put that in parentheses. And then to the nth minus 1. So 152 times the quantity of negative 1/2 and to the n minus 1 power. Okay? All right. Now, we're going to go ahead and for these two questions that we just did, okay, we're going to find a sub 7, okay, because that's part of the question. So we found the rules for both, but how would we be able to find a sub 7 once we know the rule? So this might be something that you're familiar with since we talked about it in when we did arithmetic sequences. Overall, yeah, you guessed it. We're going to go ahead and find a sub 7 by substituting 7 in for n into the equation. So here's our equation for 2a. And so we're going to substitute the 7 in here. So when we substitute 7 here and here, we're going to get a sub 7 is equal to 4 times the quantity of 5 to the 7 minus 1. So again, order of operations, got to simplify the exponent here first. There's nothing we could do in parentheses, so we skip that, then we go to exponent. Since the exponent needs to be simplified, we can go ahead and subtract 7 minus 1, and that will give us 6. Now we're here. We either can multiply or do exponents first. According to order of operations, again, PEMDAS, we have to make sure we do exponents first, so we have to do 5 to the 6th power first. When you do 5 to the 6th power, you're going to go ahead and do that with a scientific calculator. And then once you do that, you multiply it by 4. Once you multiply it by 4, you're going to get 62,500. So a sub 7 is equal to 62,500. Feel free to pause the video here to check that, and just to make sure you're able to know how to use a calculator. Now, even though I'm specifying here that you could use a scientific calculator, you can always do this on your own by showing all the calculations on the side. So you really don't need a calculator. It just saves some time, okay? There's some other calculators that you can just put the whole thing. So you can put 4 times the quantity of 5 to the 6th power and then click enter, and it'll give you the answer. So you could do it either by parts, like you were to do it on paper on your own without a calculator. So you do exponents first and then multiply, or you could just do it all at once if you're using the calculator. So please make sure you practice using the calculator and making sure you get this answer as well, as you are going to be expected to know how to do that in the future. Okay. All right. So now that we did 2a, we found a sub 7. We're going to go ahead and come back to 2b and do the same thing, but with the rule that we just found. So for 2b, we found the rule as 152 times the quantity of negative 1/2 to the n minus 1. So in this case, we're finding a sub 7. So a sub 7 means that n is 7. So we're going to substitute 7 there, and we're going to substitute 7 here as well. So notice I already substituted them here. And then, just like we did with the last one, we're going to simplify the exponents here first. That gives us 7 minus 1 is 6 again. But again, now this one here, instead of multiplying again, because we have to follow our operations, we have to do negative 1/2 to the 6th power. If you do negative 1/2 to the 6th power and expand it, that means you're multiplying negative 1/2 times negative 1/2 times negative 1/2 times negative 1/2. Basically, 6 different times you're multiplying negative 1/2. So when you do that calculation, you're going to end up with 1 positive 1 over 64. Now, remember that's going to be end up as a positive answer because we have a negative number. We have even number of negatives being multiplied, right? Or if you multiply 6 negatives, then you're going to end up with a positive answer always. Okay. So again, any even exponent, if you have a negative inside that you're multiplying number of times, even number of times, it's always going to end up a positive. If it was an odd number, then you end up with a negative answer. Okay. All right, so now that we have that out of the way, again, coming back to this problem, so you have 1 over 64, and then we're going to multiply that by 152. So 152 times 6 divided by 64, they have a GCF of 8. So when I divide it by 8, I am left with 19 over 8. Okay, and this is your final answer for a sub 7. So a sub 7 in the sequence, it's going to be 19 over 8. So yeah, so if you look at the sequence that we have up here, we're going to end up with fractions if you keep going all the way through to a sub 7. That's what that means. And for 2a, our a sub 7, it's going to keep growing at 62,500. So you can just imagine if we were asked to do even higher a sub, like maybe 100, it's going to be a pretty huge number. Okay. All right, we're going to move on. Feel free to again to pause the video before you go on to the last part. All right, for our last part here, we're going to go ahead and continue writing rules, but this time we're going to write a rule when they give us a term and the common ratio. So when they give us the term, a specific term and a common ratio, then you're going to be able to figure out the rule. Now notice it says a term. It doesn't say the first term, right? So in order for us to find the rule, we need to find the first term and we need the common ratio. So that's the trick to this problem. So here's an example. One term of a geometric sequence is a sub 4 equal to 12. So again, it's a sub 4 given to us equal to 12, the fourth term in the sequence. Then they say the common ratio is r equal to 2. So the common ratio r is 2. Write a rule for the nth term. Well, how do we approach this? Well, if you want to find the rule, we need to figure out the a sub 1, the first term. So we are going to use the rule for a geometric sequence and then substitute what they give us right now. So we're going to substitute n, and right here a sub n is 4, right? So we're going to use n with 4. So substitute n with 4. And then they also give us r, the common ratio, which is 2. So we're going to substitute n with 4 and r with 2 to find a sub 1. So again, make sure you know your rule. The rule is, again, a sub n equal to a sub 1 times the quantity of r to the n minus 1. So you're going to write that out every single time. Make sure you know that. And then, again, That will make it very easy to go ahead and just start inputting what they give you to figure out what you don't know. So in this case, we know that a sub 1 is not given to us. So that's what we need to find, question mark. We know that a sub 4 equal to 12 is given to us. A sub 4 means that your n value is 4. And we know that overall your a sub 4, this fourth term in the sequence, is equal to 12. Okay, we're going to be using that as well. And then r equal to 2, the common ratio is 2. Okay, so right here, our a sub n, so we know n is 4, so we're going to substitute n being 4. A sub 4, and we're going to rewrite it equals a sub 1. We don't know what the first term is. Okay, that's our job. We need to find that out, okay, by using the other pieces of information. All right, our common ratio, it was given to us, is 2. So again, follow the arrow here, substituted 2. And again, we do know what n was because they gave us one of the terms here, a sub 4. So we're going to use 4 minus 1. Use whatever they give you. And then from here, we know that a sub 4 overall, we know that is 12. Okay, so we're going to substitute a sub 4 with 12 here. And then a sub 1 stays the same. Can't do anything with that. Again, that's what we're finding. We do know that we could simplify 4 minus 1 here, which is 3. That's how we get 3 here. And then 2 cubed, when we multiply this out, we're going to get 2 times 2 times 2, which is 8. Okay, so since we need a sub 1 by itself, now we're going to go ahead and do the division by 8 because we need to get a sub 1 by itself. So again, divide by 8 here, that's going to give you a sub 1 or 1 a sub 1, which is just a sub 1. And then 12 over 8, they have a GCF of 4. So you divide that, it's going to give you 3 over 2. So we just found our first term. Now, our first term, you could write as a fraction or you could write as a decimal, okay? I'm going to just go ahead and write it as a decimal. So I'm going to use 1.5 when I rewrite the rule. So it's up to you what you want to use. If you want to use 3/2, again, just make sure you know how to do both. Just depending on how they give you the questions in the future or in a test. All right, so now we found our a sub 1. What do we do with that? Again, what was the goal? Our goal was to write a rule for the nth term. In order for you to write the rule for the nth term, we need to make sure we know the a sub 1, the first term, and we need to know the common ratio. So the common ratio was given to us, which was r equal to 2. So pretty much what we're going to do is we're going to use our rule, our general rule here of geometric sequences, and we're going to substitute a sub 1 and then the r, which is the common ratio. And then we're done. Okay, so here we go. All right, so now that we find a sub 1 again, we're going to find the rule of the nth term by substituting the a sub 1, the first term, and the common ratio r into the rule for a geometric sequence. So notice I wrote down here, a sub 1 is 1.5, and my common ratio is 2. So you write down and substitute to get our nth term. Our nth general rule is a sub n is equal to 1.5 times the quantity of 2 to the n minus 1. So again, a sub 1, we just found out. A sub 1 right here, the first term. And then r equal to 2, the common ratio was already given to us from the beginning. So you just substitute that. And again, do not touch the exponent of the n's because again, you're finding the general rule of the nth term. Okay? And that pretty much summarizes the Learning Target 9C. For homework, you can expect to go ahead and do homework number 26. You can expect to do these problems here from page 814 all the way to 815. There will be some review problems moving forward next week on this, so feel free to ask questions, and I'll be having a Q&A session tomorrow. Feel free to log in and then also be prepared to ask questions, okay? It's optional, but at the same time, you can also stop by to say hi, okay? Looking forward to seeing you guys. It's a short week. I'm glad you guys are doing okay from what I heard for the most part. Feel free again to reach out for any reason. All right. Talk to you guys soon.